Hi, everyone. I'm going to lead you through our complex number notes. And a complex number means that it involves the imaginary unit or the imaginary number, which we represent with the letter I. So the imaginary number or imaginary unit is equal to the square root of -1, right? So typically we can't take square roots of negative numbers, but by creating this imaginary unit, it allows us to take square roots of all values, positives and negatives. But when we involve I, that's what makes this a complex number. And we're going to get to that in a second. So I, or the imaginary number, is equal to the square root of -1. One thing that we're going to have to use down the road is we're going to have to figure out what is I squared. Well, let's think about this. If I have I squared, that really means the square root of -1 squared. Well, what happens to a squaring and a square rooting? They undo each other. So those two things cancel each other out, leaving us with just -1. So I squared is equal to -1. It gets rid of the I itself. So if we have two imaginary units multiplied by each other, that gives us just -1. It gets rid of that imaginary unit, right? So that's our imaginary unit defined. And when we involve the imaginary unit, that allows us to come up with a different set of numbers. So the set of numbers in the form of this is A plus BI is called the set of complex numbers. So complex numbers means that we just involve the imaginary unit or that we involve I. So this I here, that's that imaginary unit. So anything with I is our complex number. All right, if B does not equal 0 from this complex number, so meaning if B is some number, then the number is also called an imaginary number. Okay, imaginary, complex, either one you want to use there. If B equals 0, well, what does that look like? So if A plus B, but B is 0 times I, well then 0 times I, that's just 0, and we're left with just A. So when B equals 0, we have just A, then we call that number a real number. Those are the numbers we typically use, right? Real numbers are 1, 2, 3, 4, 5, all of our counting numbers, right? So just some vocabulary there. All right, here's some operations that we can do with imaginary numbers. And we treat them just like we would if we were combining like terms. So if I have -9i plus 2i, that's just -7i. So we're literally just doing -2, or excuse me, -9 plus 2 to get -7. Same thing with subtracting. If I'm subtracting, I'm going to distribute this negative. So this is 3i plus 5i, which is 8i. Okay, and the last thing we have here is some multiplying. If I am multiplying all of these terms, we need the FOIL, and some things happen. So if I do 6 times 5, that's 30. If I do 6 times -3i, that's -18i. 5i times 5 is 25i. And 5i times -3i, well, let's think about this. If I had -5x, or excuse me, 5x times -3x, let's go ahead and do that. Times -3x, I would do 5 times -3 to get -15, and x times x is x squared. So when I apply this to our imaginary numbers, 5 times -3 is -15, and I times I is I squared. We know what I squared is, right? We just defined that up here. That's -1. So when we go to simplify this, we have 30, -18i plus 25i is 7i. And then -15 times I squared is really -15 times -1. When we simplify -15 times -1, we get a positive 15. And now I have 15 plus 30, which gives us 45 plus 7i. So when we multiply these complex numbers, it takes a few steps to get to the final product, but it ends up being 45 plus 7i. Make sure you're foiling, right? Drawing those arrows and getting everything multiplied together. All right, a few more things. One thing you're going to hear quite a bit in pre-calculus is the word conjugate. Conjugate just means keep all of our complex units. This is a complex number, complex unit, keep it the same, but change the sign. So the conjugate pair of 4 minus 9i is 4 plus 9i. So I'm only changing the sign in the middle. Why we do that is because the conjugate is what allows us to get rid of the imaginary unit. So if I were to do 4 minus 9i times 4 plus 9i, we're not going to have any imaginary units at all. And let's look at that. So 4 times 4, that's 16. 4 times 9i, that's 36i. Negative 9i times 4 is negative 36i. And then negative 9 times 9 is negative 81 times I squared. Well, 36i minus 36i disappear. Then I have 16 minus 81 times I squared, which is negative 1. So 16 plus 81, and this would be 97. So that's what the conjugate does. The conjugate allows us to get rid of or move out of the complex numbers into a real number system. So again, conjugates are just change the sign in the middle. And the way it always works out, that we'll get rid of that I. All right, so eventually, we're not going to do this today, but eventually we're going to take imaginary units that are being divided, and we're going to need to rationalize the denominator, which means in our denominator, we need a real number. To get that, we need to multiply by the conjugate, where the conjugate of 8 minus 7i is 8 plus 7i. By multiplying by 8 plus 7i, that's what's going to get rid of the complex number in our denominator, giving us just one whole complex number that is not a fraction anymore. All right, so those are just some properties of the complex numbers. Let's look at how we're going to actually use them in this class. So like I mentioned at the beginning, by coming up with the imaginary unit, this allows us to take square roots of negatives. So if I take the square root of negative 931, the first thing we need to do is remove the square root of negative 1. By removing the square root of negative 1, we have made this an imaginary unit or complex number. So we have I times root 931. So that's this first blank here, is I times root 931. Then we can factor down 931 to be 49 times 19. We can check that. 931 divided by 49 is 19. So this is just I root 49 times root 19. And then really what we would do is we take the square root of 49 times the square root of 19, and we know that that's 9. So really this is 9i times root 19 is equal to the square root of negative 931. All right, so anytime we're taking square roots of negatives, we're going to factor out the negative 1, make it an imaginary number, and then reduce down the rest of the radical. We're going to need to do that when we get to the quadratic formula. So this is nothing more than the quad formula, where the values have already been plugged in for us. So our task for this last little note here is going to be to simplify this. So when you're using the quadratic formula, I always suggest let's do some side math with this square root. And what I mean by side math is, I'm going to rewrite that square root down, and I'm going to work on simplifying this before I do anything else with that whole equation. So 6 squared I know is 36. And then this is 4 times 3 times 4. So minus 4 times 3 times 4 would be times 3 times 4, 48. So minus 48. So really we have the square roots of negative 12. Well, we need to reduce this down. And in order to reduce it down, we first need to factor out the negative 1. So we still have square root of negative 1 times the square root of 12. The square root of negative 1 is I. And then if we want to reduce down root 12, we need to factor out a perfect square. The only perfect square that divides 12 is 4. So this is really root 4 times root 3, where root 4 is 2. And root 3, we can't reduce that down at all. So this whole square root works out to be 2i root 3. So with this side math, we have now decided that this whole square root is 2i root 3. So now that I'm done with my side math, I still have negative 6 plus or minus, but that square root is 2i root 3 over 2 times 3, which is 6. So from here, with our quadratic formula, this plus or minus means we have two values. We're going to have one where I do negative 6 plus 2i root 3 divided by 6. And then another one where I have negative 6 minus 2i root 3 divided by 6. Now, when we're dividing by 6, we're dividing anything separated by a plus or minus sign by 6. So this is really 6, or excuse me, negative 6 divided by 6 plus 2i root 3 divided by 6. And over here we get 6, negative 6 divided by 6 minus 2i root 3 divided by 6. And some of these things reduce down. Negative 6 divided by 6, that's negative 1. When I have 2i root 3, we just need to divide the other number by 6. So 2 divided by 6 reduces down to 1/3. So we don't need the 1 up top because multiplying by 1 doesn't change anything. So it's really I root 3 divided by 3. And our last complex number, negative 6 divided by 6 is negative 1. Once again, we get that negative 2 divided by 6 is negative 1/3, leaving us with negative I root 3 divided by 3. And these are those values of x that we get from the quadratic formula. All right. Well, that's everything I have on your complex numbers. Thanks for watching and have a great rest of your day.